Before we get to 3.5, we've covered a lot of ground between 3.1 and 3.4. A lot of derivative rules, a lot of examples. We're getting introduced to just new sorts of problems now that we're able to take derivatives more quickly. So I thought it'd be a good idea. Let's just pause here. This is going to be a very, very fast review. We're just going to recap the rules quickly and then do a couple of what I think are kind of key examples of just taking derivatives, and then and that'll be it, and we'll move on to 3.5. Okay. Don't get your hopes up here with this review, is what I'm trying to say. Here are the key rules so far. I did not include the trig derivatives because that would double the list almost. Here we go. So this was the first one we learned, the power rule. Derivative of x to the n, nx to the n minus 1. Okay, derivative of a constant is 0. Not to be confused with the derivative of a constant multiple, c times f of x. In that case, the c just carries along, and we multiply it by the derivative of f of x. We have the derivative of e to the x equals e to the x. Okay. And then really big, the derivative of a product. And you notice I am doing some shorthand here. I'm not writing the of x for both of them just to make it a little simpler. The derivative of f times g, f prime g plus f g prime. Derivative of f over g, g f prime minus f g prime all over g squared. Low d high minus high d low, all over the low squared, and away we go. And finally, the derivative of a composite function, f of g, derivative of the outside times derivative of the inside, f prime of g times g prime. Okay, so I just wanted to look at a couple of derivative cases that's going to encompass all or most of these rules. We're going to throw some trig in here as well. So I've got, I think, 3 or so of these. Okay, let's start with something fairly simple. How about the sine? F of x equals the sine of 5x. Okay, well, this is a composite function. We have an inside and an outside. Okay, the sine of 5x, just like f of g. So if we were to take this derivative, here it is right here. Well, I'll just show it to you. The derivative of sine, you may remember, is cosine. And we just copy the 5x at this point. Then we multiply by the derivative of that 5x, which is 5. And writing it a little bit neater, let's just say 5 cosine 5x. Okay, we got a very simple chain rule there with a trig, but hey, if you don't know the simple ones, you're never going to get the tough ones. So let's be really, really confident in those simple ones, and then we can grow out of that. You always want to be practicing the basics, the fundamentals. Okay. Ooh, how about this? Y equals the square root of tangent x. We didn't see anything like that in the trig section, at least not in the lecture, that's for sure. Okay, the square root of tangent x. So we're going to think of that as tangent x raised to the 1/2, right? And if you think of it this way, well, we've got another chain rule. We've got an inside, tangent x, and the outside is that power. And so here it is. Y prime, well, the derivative, the 1/2 would come down to the front. It would drop to a negative 1/2 when we subtract 1. And of course, we just copy the tangent x for now. And we will multiply by the derivative of the tangent x, which you may recall is secant squared x. So this looks very nice right here. You might prefer to leave that if you don't have to simplify. But how else might it look? Let's just see it for practice. With a 1/2 and then with a negative exponent here, these could both tuck into the denominator. So that 2 would go down, and then if we thought of tangent to the 1/2 going down again, well, that would, maybe you think of it as the square root of tangent x in the denominator. And that secant squared x could sit on top. Okay. And I've got one more. This will be a good one. There's so many rules, so many combinations. You really want your derivatives rock solid. And not for just chapter 3. I mean, this is laying the foundation for the rest of the course. If your derivatives are not very, very strong, by the time we move past that, then well, let's just put it this way: you want them to be very, very strong. You'll be in a very good position. Okay, y equals x multiplied by e raised to the x squared plus 1. So there's two rules going on here. You may notice there's a chain rule because x squared plus 1 is in the power of e. There's also, the bigger picture is a product rule. So we got this product rule, but within the product rule, we're going to have a chain rule because when we go and take the derivative of the second function, that needs a chain. Okay, well, here it is. Just wrote the whole thing out. Y prime, our product rule would say 1 times this left alone, so we just copy it, plus copy the x times, and now here comes our chain rule. What we see right here, of course, is the inside. So the outside is e. That all just copies over. Multiplied by the derivative of x squared plus 1 is 2x. That's your derivative. Let's make it look a little bit neater. Y prime equals e raised to the x squared plus 1 plus this would become 2x squared e to the x squared plus 1. That's your review. We're moving on to 3.5 next.